Hi, pre-calc students. In this video, we're going to be looking at section 5.2 on power functions and polynomial functions. So you've seen these all before. It will be review. Power functions are of the form f of x equals k times x to the p power. So let me give you an example. Maybe we have f of x equals 5x squared. It's a power function. Now, k and p are real numbers. K is called the coefficient. So my coefficient in this example is the 5. Now, if we want to talk about a polynomial function, that's where you put a bunch of terms of a power function together. So let n be a non-negative integer. So we're talking 0, 1, 2, 3, etc. And a polynomial function is a function that can be written in the form f of x equals a sub n x to the n plus all the way down to a sub 2 x squared plus a sub 1 x to the first plus a naught. Now, this is the general form of a polynomial function. Each a sub I is a coefficient and any real number, and can be any real number, but a sub n cannot equal 0. And each expression is called a term of the polynomial. So giving you an example, say we have f of x is 4x cubed plus 7x squared minus 9x plus 5. So each of these are terms. So a sub 3, because the third degree term, a sub 3 is the coefficient, so it would be 4. Here, a sub 2, we would say was 7. A sub 1, we would say was negative 9, and we call it a sub 1 because the x has a 1 exponent there. A sub 1 would be negative 9, and a sub 0 would be 5. Now, other terminology for polynomial functions. Let's see, we often rearrange polynomial functions to put the highest power first, and we call that the leading term. We call the leading or the highest power, we call the degree of the function. And the term that contains the highest power is called the leading term. And the coefficient of that leading term is called the leading coefficient. So once again, if we looked up here, my lead term would be the 4x cubed, and the leading coefficient would be 4. And the degree of the polynomial is 3. Let's look at a different example. Say we had this one, where we had f of x was 4x squared plus 7x to the 5th minus 5. In this one, we are not put in descending order, but don't be fooled. This would still be our leading term because it has the highest exponent. The degree of the function would be 5. The power or degree of the function is 5, and the leading coefficient is 7. We will refer to these, so it's good for you all to know what we're referring to when that happens. Let's go ahead and talk about end behavior. When we talk about end behavior, what we're talking about is what happens to the function as you approach positive and negative infinity. So if you have a graph, say my graph looks like this. We're talking about the end behavior of the function. So what happens here and what happens here. The end behavior is not, oops, I'm trying to erase just that. Okay, well, the end behavior is not what happens in the middle. So let's go back here. Well, it's not doing it. The end behavior is not what happens in the middle. It's what happens on the end as x approaches positive infinity and negative infinity. So if you have an even degree function, so if your exponent, if the highest power on your function is even, then as x approaches infinity and as x approaches negative infinity, the y values approach infinity. As you go, yeah, the y values approach infinity. So let me show you what that looks like. If your coefficient is positive, if your lead coefficient is positive, and you have an even degree function, and what that will look like is this. You may have an axis there, and then as you go to negative infinity and positive infinity, the y values go to positive infinity also. Now, if we have an even degree function, but your lead term has a negative lead coefficient, then what's going to happen is as x goes to negative infinity and positive infinity, the y value will go to negative infinity, go to approach. So what that looks like is this. I'm not talking about what happens in the middle, but let me give you an example. Say we have the function f of x is 3x to the fourth minus 17x squared. My lead term has an even degree, so we're in this column, and my lead coefficient is positive. So what this function is going to look like is that the end behavior as x approaches negative infinity or positive infinity, both ends go up. Now, if there had been a negative in front of that 3, the way it would change the graph is that the end behaviors would approach negative infinity. So the graph might look like that. They would go down. All right, let's go on to an odd function. Odd functions would be if the exponent was like 3, 5, or 7. Then what's going to happen is this. As x approaches infinity, if you have if your lead term is positive, as x approaches infinity, your y value will approach infinity. And then as x approaches negative infinity, your y value will approach negative infinity. So what this looks like is this. As x approaches infinity, the y value approaches infinity, so it's going up. But as x approaches negative infinity, the y value will approach negative infinity. So if the lead coefficient is positive, then the end behavior of your function will look like that. In the opposite regard, if you have a negative lead coefficient, then as x approaches infinity, your y value will approach negative infinity. And vice versa. As x goes to the left, your y value will go up and approach infinity. So that looks like this. All right, so as x approaches infinity, your y value approaches negative infinity. That's this. And as x approaches negative infinity, your y value approaches infinity. That's that. So the end behavior is what happens as x approaches infinity and negative infinity. Let's look at a question or another concept here. So turning points. A turning point of a graph is a point at which the graph changes direction from increasing to decreasing and from decreasing to increasing. The y-intercept is the point at which the function has an input value of 0. So when x equals 0, And the x-intercepts are the point at which the output value is 0. So y equals 0. We saw that in our last section as we looked for x and y-intercepts in quadratics. But let's talk about turning points for a second. So if I have this function, we'll graph it in blue, like that. These are the turning points right here and right there, changing from increasing to decreasing and decreasing to increasing. Those are turning points. And if a polynomial is of degree n, it will have at most n x-intercepts and n minus 1 turning points. So let's look at a function that has an x to the 5th in it. I don't know what the coefficient is. And we'll call this a sub 4, x sub 4, a sub 3, x sub 3, etc. So if it's got a power of 5, it can have as many as 5 x-intercepts and 4 5 minus 1 turning points. So 5 x-intercepts would look like this. 1, 2, 3, 4, 5. 1. That's 5 x-intercepts and 4 turning points. 1, 2, 3, 4. That's what this is telling us. So let's look at example 1 and see if we can answer some questions about example 1. Example 1 says, find the degree, the leading coefficient, the maximum number of x-intercepts, the maximum number of turning points, the y-intercept, and describe the end behavior of each function. Oh, that's a lot. All right. So here we have x times x minus 3 times x plus 3. Now, we know if we multiply, let's not even multiply it. If I multiplied this x here, this times that would give me x squared. And I'd have x squared minus 3x. Then if I multiplied that by x, I'd have an x cubed. So this is of degree 3. This function is of degree 3. The leading coefficient. All right, so if I multiplied these together, if you actually multiplied it out, you're going to have x cubed minus 9x squared. You guys can multiply that out, but the leading coefficient would be 1. Now we can see that here. Let's make this smaller. Because there's no coefficient of the x here, and none of these x's inside the parentheses have coefficients either. So it's understood to be 1. So my lead coefficient is 1. Which is positive. Now the maximum number of x-intercepts. Since my degree is 3, the max number of intercepts, x-intercepts, is 3. And then the maximum number of turning points. Okay, so we just learned above that if the degree is 3, the maximum number of turning points is 2. And the y-intercept. Okay, the y-intercept here. If we look at the y-intercept, we learned from above the y-intercept is found by letting x equal 0. So if I let x equal 0, then my y value will be 0. So the y-intercept is 0. And describe the end behavior of, oh wait, yeah, describe the end behavior of the function. All right, knowing that it's of degree 3, that's an odd degree. And we have a lead coefficient, which is positive. So let's go back up here and look at what that means for our graph. We have an odd degree function, and the coefficient, the lead coefficient is positive. So what that means is our end behavior is going to look like that. As x approaches infinity to the right, my y value approaches infinity and goes up. And as x approaches negative infinity, my y value will approach negative infinity. That's what this says. So let's write that in question 1 here. So the limit, this is end behavior. It's really 2 words, but the limit as x approaches infinity of my y value is infinity, and the limit as x approaches negative infinity is that my y value will equal negative infinity. All right, we have answered all the questions for this one. In our next video, we will finish up this section. Thanks for watching.